Hi guys, so here we are starting a new topic, sequence and series. These are number patterns, guys. So number patterns, we're going to look at the arithmetic patterns. We're gonna look at the geometric uh, sequences, and we're also gonna look at the quadratic sequences. So let us start with the arithmetic sequences, also called the linear patterns. So suppose you have a sequence. Look, a sequence, it's it's an instance or an occurrence where you have items preceding other items. Like for example, if like you wake up and you have chores, wake up, take a shower, have breakfast, go to work or you go to school. You see, that's a sequence. An activity preceding the other activity. So here, a sequence can simply be to say you have a term following another term, and then there's a relationship between these two terms. So in arithmetic sequence, what is happening is you have a term, which is term number one. So this is going to be term number one. This is going to be term number two, and then this is going to be term number three, like that. These are just terms. It's just like a value on a certain space, on a certain term, just to put it simply. So you have term A, for term one, we have A. So let's say for term one, for period one, you have a value called A. For term two, you have a value called B. And for term three, you have a value called C. So a value, guys, just means like a number or anything. So their relationship in arithmetic sequence is that they are related. If a sequence is to be classified as arithmetic, therefore, when you subtract term 1 from term 2, you get the same difference when you subtract term 2 from term 3. So meaning we have to get a difference here. And that difference, how do we get it? We're going to say term 2 minus term 1, which should be equals to term 3 minus term 2. So that is what's happening, guys. You just take a term and subtract the term before that one, and then you get the difference. You cannot say C minus A. You take the closest, the one before, So it's going to be term 2 minus term 1 or term 3 minus term 2, depending on which values you have. And that's going to give the difference in the sequence. So term 2 minus term 1 is the same as B minus A, and this is equals to C minus B. The difference should be the same because it grows with the same difference. So here you calculate D, what we call a common difference. It's a common difference. Common difference is the same number that they differ with term by term as you go in this sequence. Let's look at a practical example. So guys, look at something in a sequence. If they say what is term 1, term 1 is just A, right? So this tells us that term 1 equals to A, and A is what? A is the first term. So term 1, T1 equals to A because of that, right? So I want us to get it, guys, and let's look at it like that. So from here we can spot the relationship. We can spot the relationship, guys. Let us do this. Let us do an example. If we have a sequence minus 3 and say we have minus 3, also have 1 and 5 and what can I, oh yeah, or we can just stop at 9, and obviously up to certain 10. So let us look at this. So if I try to do this approach of calculating D, let's find D. I want to find D. So D is what? T2 minus T1, right? There's going to be T2. This is T2 is term number 2. This is term number 1. So T2 minus T1 is going to be 1 minus negative 3. You see that? Because this is term number 1. So it's going to be 1 minus into negative 3. So this gives us what? The positive 4. Negative, negative, positive. And then here you come here is going to be term 3 minus term 5 minus 1 equals to 4 as well. This side, term 4 minus term 3 is what? 9 minus 5. This also equals to 4. So the common difference is 4. So if you are able to get this, if you are able to get the difference being the same like that, then this tells you that you are dealing with what? You are dealing with an arithmetic sequence. Arithmetic sequence. I hope that makes sense. So if you have this, let's look at it in another form. So if you have this and the common difference is 4, how can we move from negative 3 to get 1? What happened from negative 3 in order for them to get 1? You know, if they know the difference. Look, it's like this. If you know term 1 is negative 3, you know term 1, you know the value of term 1. And you know the common difference. The common difference is 4. So from here, they say find term 2. So what you do, term 2 is just going to be term 1 plus the common difference. You get what I'm saying? Because you're moving from here going to the next term, and you know they differ by D. So term 2 is going to be what? T2 is going to be T1 plus the common difference, and T1 is negative 3. Sorry, let me get T1 is A. T1 is A. T1 is A because it is the first term, right? T1 is equals to A. So this is the same as A plus D, right? So meaning if you know A and you know D, the common difference, don't mix D with this D that you find on the sequence. This D is the common difference. So if you know A, which is the first term, if you know the first term and you know D, which is the common difference, then you can find term 2. In our case, term 2 is minus 3 plus D is what? It's 4. So term 2 equals to negative 3 plus 4 equals to 1. See? So term 2 equals to 1. And that 1 is that 1. See, I'm just proving that you can actually get it like that. I'm just showing you that you can actually get it like that. So term 2 equals to 1, term 1. There we go. We have it there, we have it there. So if you want term 3, term 3, for example, now we have term 2, we need term 3. How would you find term 3? Using term 1. The only given is A. So look, obviously, if you are moving from term 2, right? If you're moving from term 2 to term 3, is the same thing as term 2 plus D, right? Because the difference is D. The only thing we're doing is adding D. Let's take it down here. The only thing we do is add D. So we're gonna take term 2 and add D. And term 2 is what, guys? Term 2 is this part, right? Term 2 is this part. Term 2 is A plus D. So let's say, so now we're adding term 2 plus, so term 2 is A plus D. So term 3 equals to term 2 plus, yeah guys, so term 3 is simply term 2 plus d, and term 2 is let me use a different color. Term 2 is a plus d, and then system plus g. Now I'm adding that plus g. So this gives us a plus 2. So term 3 is a plus 2d, and term 2 is a plus d, and term 1 is what? Term 1 is a. 1 is a. Yeah? Okay, let's go to the next page. Let's, okay, so term 1, term 2, and term 3. Yeah? We're only doing 3, but always make it like I'm just to explain. So term 1 is what? Term 1 a. Term 2 is what? Term 2 a plus g, and term 3 is what? A plus look, the way I look at it, I can write term 4 here. Term 4 is going to be what? A plus 3d. Look at this. It's a plus d, a plus 2d, then the next one is a plus 3d, the next one is a plus 4d, just like that. So let us look at the relationship. The relationship here, we want to write this in the form of n, so that if they say find the nth term, you can still be able to do it, see find the nth term. So we need to find a relation, a way in which we can write it to represent this part using n, so that if they say find the nth term, we can do that. So let us look at the relationship. When for term 2 we have 1d, for term 3 we have 2d. So do you see the relationship? So this is 2, this is 1, this is 3, this is 2. Term 4 is going to be 3d, so it's going to be 4 and 3. So because of that, I'm going to write it mathematically like this. I'm going to write it like a plus, I'm going to write the sequence like this, t n equals to a plus, it is a plus, right? So it should be a plus d or a plus, see here, 2d, 3d, and all that. So I find a way to represent that. So I'm going to write this n minus 1 multiplied by d multiplied by d. I want us to look at something. Look, why am I saying this? The reason is I'm saying we want to write this formula in a way that can find any term in the sequence. Now look, if they say find term 1, we know term 1 is supposed to be a, right? So you'll simply say term 1, n equals to 1 for term 1. So this one here, base 1, represent tn, tn, t1. So n is represented by this number. So if they say find term 1, it means n becomes 1. This part. So it's going to be 1 minus 1. It's going to be 1 minus this one. It's going to be 0. So 0d multiplied by 0 is 0. This whole part is going to be 0. You will remain only with a, which is correct. T1 is a. And if they are speaking about term 2, you'll say 2 minus 1 is going to be 1. 1 multiplied by d is going to be d. So you'll have, for term 2, you'll have a plus d. See, that is correct. For term 3, you'll have term 3, n is going to be 3. N minus 1 is going to be, terms d is going to be 2d. It's going to be a plus 2d. Here it is. So you see, comes correct. So we just found a way to represent the whole sequence mathematically. So we're going to use this. So this is the formula that we're going to use to find terms, find the values and of terms in the sequence, or if you are given the value of a term and they want you to find which term number that is, will use formula to this formula. Okay, let us go back to first sequence given. Let us go back to our first sequence. So we had -3, we had 1, we had 5, we had 9. Okay, that's that. And then let's say the last term is 3, 9, 3. So we have this. So from here, what is the value of a? The value of a is equals to -3, because a is t1. As a is t1, term 1 is equals to a. Because if n is 1, is 1 minus 1 is 0. They only remain with a. So t1 becomes a. T1 is a. Already explained that. And then we need the common difference. Let's find d. Sorry, guys. Question 2. Let's find d. D is the common difference. D, remember D is what? T2 minus T1. So you can use T2 minus T1, or you can use T3 minus T2, or you can use T4 minus T3, depending on which you are given in the sequence. Okay? So T2 minus T1 is going to be 1 minus 3, because T2 is 1, minus T1. T1 is negative. So this gives us positive 4. So D is positive 4. So the next part is to write the general equation. This is the general equation. So Tn is equals to a plus into n minus 1 d, right? I'm just going to substitute that. So Tn equals to a is -3 plus n minus 1 times 4. Let's simplify it further. So if they say write the general equation of that, so we wrote it here using this formula, right? This standard formula. So here I'm just expanding. It's -3, then -3, and plus 4 times n is 4n. 4 times -1 is 4. So you see -4, so we have 4n. -4, -3 is -7. 4n. So this is the general formula for this. So if you want term 1, just substitute 1 where you see n. So 1 is going to be 4 minus 7. It's going to be 1 multiplied by 4 is 4, minus 7 is -3. If you want term 2, you substitute 2. So this is 2 times 4 is going to be 8. 8 minus 1 is going to be 1. If you want term 3, you'll say 3 times 4 is 12 minus 7 is 5. Just like that. Term 4, just like that. 4 times 4 is 16. 16 minus 7 is 9. Yeah? 4 times 4, yeah? 4, yes, it's 16. 7 is 9. So this is it. So this is how you find the general formula for that. Look, guys, I'm just playing around with, but obviously we're going to do questions from a question paper. I'm just playing around with the relationship. Oh, how to get these things. So if they say, for example, if they say number 4 here, find the term number for the value 393. You see 393 is on the okay, look, we found 1, 2, 3, 4. If they say find the term number for 393. So T n equals to, you can use this one or you can use this one. So let's use that one now. A plus n minus 1, the general formula here, this one. So The value is, see, the value is this 393. So 393 equals to A is negative 3 plus into n minus 1. Because we want n, we want the term number, t something value, the term number, the value of that term we have it is 393. This is the value of a term, but we want to know what term number is that. Is it term 1? Is it term 2? Is it term 3? Is it term 4? Is it term 5? No, that's what we want to find, and that is represented by this n here. So from here, what happens is it's just a simplification. So basically, it's the same thing as taking this and writing 393 and solve it for n. So 393 plus n is going to be, okay, I'm going to take this 3 that side. This part, if I expand it, 393, if I expand this part, bring us down, right? 4n 7. So I'll take 7 to the other side, it becomes positive. So 3, this is 393 plus 7 plus 4n. 393 plus 7 is 400, right? And 400 equals to 4n. 400 divided by 4. Yes, I'm just checking if I did not make any mistake. Second, just check. Yes, so this would make sense. Let's get a bit. 3, no, so it's 4, that 4n 7, 740, 400, 4. Alright, then n equals to 100. And you check it like this. You can check it, multiply it. Just substitute n here. If I take n, I the formula here. 100 times 400 minus 7, 3. So yes, it is correct. So this is the n value term. Like 393 is the value of term number 100. Term number 100, the value is 393. If they say find term 10 for term 6, for example, find term 6. Wait, 1, 4. Let's find term 5. Find 5. Term 5 is going to be what? You'll just write this as it is, minus 3 plus into n is going to be 5. It's n. It's the term we want, 5. Minus 1 multiplied by d, which is 4. That's 4. Then you just solve this. So this is 5 minus 1 is going to be 4 times 4. 16 minus 3 is 30. So T5 is going to be, so it means the term that comes after 9 is positive 30. And because we already know the difference, we can see 9 plus 4 and 8. The difference is 4. 9 plus 4 and 8 plus 4, 17, 4 is 1. Just like that, because we know the common difference. Okay, guys, this is it. So let's try to solve a let's solve a question of this type. But before we do that, let me quickly write something. So what we did there, we were finding the terms Tn equals a plus n okay, minus 1. So this is the formula for finding the term number or term value, right? So another formula that we're gonna use, I won't prove every formula we do. So another formula that we're gonna use, guys, is gonna be for sum. If they say you find the sum of the first 5 terms, or find the sum of the first, whatever terms. So that one is gonna be n over 2 in a. If I find time in the future, I'll prove it, how they got this formula. So this formula is on the question paper. You get it. These two formulas, you get them. So like this one is for finding the sum. So let's go back a bit. Let's say, for example, they say find the sum of the first 3 terms. Find the sum of the first -3, 1, and 5. Find the sum. Sum, it means you add them together. Add all those together. So if they say find the sum of the first 3 terms, it means we're going to add the first 3 terms. It's going to be this plus that plus that, right? So let us do that. So we know I can quickly do it here. -3 plus 1 plus 5 equals to 3, right? Because 5 plus 1 is 6 minus 3 is 3. So I already know that the sum of the first 3 terms is what? Is 3. So let us use the formula to try. And how many terms are there? N is the term numbers. How many terms are there? S sum to 3 terms is 3 terms. We're looking for the sum of the first 3 terms. So it's going to be 3 over a into 2 into a -3 plus into n is 3 minus 1 times 4. So 3 over 2, I'll just write it as 3 over 2 or 1.5, because remember from here you can simply do all this on a calculator, but unfortunately I do not have a calculator. I'm just solve as we speak about it. So this is going to be into -6 plus 3 minus 1 is 2 times 4, it's 8. So this is, okay, let me go back to over 2. Let me write it over 2 multiply -6 times 8 is -6 plus 8 is 2, right? So answers 2. So this is, so you see, 3. So if you can quickly do it like this, you can. And you can also use this formula. The reason, guys, you cannot always use this is because imagine if they say find the sum of the first 100 terms. If they say find the sum of the first 100 terms, how are you going to do that? You're going to first find term 6, term 7, term 8, and all that until 100. And after you have those terms, you're going to add them together. How long is that going to take? Because look, you only have 4 terms. You don't know what is term 5, you don't know what is term 6. You don't know what is term 7, and so on. So if you use the long method, you're going to have to find them first, and after finding them, you're going to have to add them one by one, like this method just, and it's going to be a lot of. So do you have that time in the exam? No, you don't. So that is why it's wise to use this formula, because this formula relates the general formula to the sequence. So here you can just say term 100, substitute 100 here, substitute 100 there, and then do the sum of the first 100 terms. So here this is the sum of the first 3 terms, is equals to 3. I hope this makes sense, guys.